Good day, metric students. Today, I want us to have a fair way of approaching this section of calculus in grade 12. And I would say it's a section where you need to be a proponent of mixed energy because it has a negative tendency of misbehaving. But if you are well inclined with grade 11 measurements, you won't subscribe to a complete collapse. And guys, if you haven't subscribed to the channel, please subscribe to the channel, guys, for more mathematics content in Mzansi context. Now, let's see what we are given just right here. They're saying a right circular cone with a perpendicular height h in centimeters and the radius of r is given there in centimeters. It has a slant height of s there, which is 12 centimeters. So it means this particular length here is 12 centimeters, and this is our h and this is our r. But those sides, they belong to a right angled triangle on the basis that you are given that is 90 degrees there, and also that is a perpendicular height. It means it forms a right triangle in there. So let's see how far we can go with that. They are saying express the radius of the cone in terms of h. So we want to express the radius in terms of h. But what I want us to also pay a close attention to is that this is a right angled triangle. So if you want the sides, you need to, do that by means of Pythagoras theorem. So now I'm going to say to myself, well, the first question, that is 4.1. We are going to say we have x squared plus y squared is equals to r squared. That is the Pythagoras theorem, where our x is the adjacent side, that is r squared, and then plus y, which is our h, and then our r, it's s. So I'm going to say this is your r squared plus your y is h squared is equals to r. But our r is given as 12, so I'm going to say it's 12 centimeters. Therefore, my r squared is going to be equals to 12 squared is primarily 144 minus h squared. So because r represent the radius, so when I square this, I'm not going to use plus or minus. I'm just going to use the positive one because the radius is always positive. So I'm going to just write 144 minus h squared. That is the length of the radius in terms of h. You get 2 marks for that. And where do you get the marks? To be able to substitute that correctly, and also to write your r there in terms of h, the simplified one. Now, we are saying the next question. Show that the volume of the cone is given by 48 pi h minus 1/3 pi h cubed. So, well, what is the volume of the cone? Everything is given to us. There is the volume of the cone there. That is 1/3 multiplied by the area of the base multiplied by the height there. So I'm going to go to the next question. It's also 2 marks, so you don't have to really sweat them. So you get 4.2. So you are going to write the volume of the cone, which is going to be 1/3, that is 1/3, multiplied by the area of the base of the cone, and that is pi r squared. And then you need to multiply this by your height of that cone, not the slant height. You use the slant height for the surface area because of that perimeter. Now, you are going to say this is 1/3 multiplied by pi r squared. But your r squared is something that you have found previously. So your r squared can be taken from that. That is 144 minus h squared. So I'm going to say, well, r squared is equivalent to 144 minus h squared there, multiplied by the height. So, well, I'm going to say to myself, let me multiply h with that first. Or you can multiply these ones first and later on multiply with h out. So I'm going to multiply 1 over 3 pi h first, and then I'm going to just double copy this one to show that I didn't do anything with this one. Now I'm going to then now say 1 over 3 times 44. You can use that in your calculator. You're going to get 48, and then you get pi h there. Now you say 1 over 3 times this situation, you're going to get a plus 1 over 3 pi h. H times h squared, it's primarily h cubed. I believe this is negative here. Please guys, it's negative because of that one. Time is a positive number there, so it's going to give you a negative situation. This is how you're going to really do the first two questions. Now we are going to the last one of the series. Extremely easy, by the way. We want to do 4.3. Calculate the height of the cone for which the volume is at its maximum. I want to warn you. Now check 4.3. They are talking about the volume. So the volume, you can see that it's a function of h, which is given by 48 pi. Remember, pi is a number. You've got your h there, and then a minus 1/3, and then pi h cubed. So we want to find the value of h for which this volume will be at its maximum. So if you look at this particular volume, it's in a fashion of cubic polynomials. And if you are to look at the structure of that, you are going to have this situation because a is negative there. So you're going to have that situation. This is when the value of a is negative, and then you are going to have the maximum there and the minimum there. So they are looking for this value here. But remember that this value of h is it's a height, so it can be a negative. Let me just really put this one here. So we are looking for a positive value because it's the height. The height is never negative. That is h. So how do you get this point here, the maximum? You actually derive your cubic stuff. So I'm going to differentiate that. This is going to be the v prime of h there. That is going to be 48 pi. And then this is going to be minus, I guess, 3 times 1/3 is a 1 there. So this is really going to be pi h squared. But this is the maximum. It means you're going to have a 0 there. That is going to be equals to 48 pi minus pi. And then you get your h squared. You can transpose this one to the left side. So you're going to get a pi h squared is equals to 48 pi. Because pi is a number, it's a constant. You can divide throughout by your pi there. And you're going to get h squared is equals to 48. Now it's a basic maths which is required of you, and that is to square both sides. Like I always say, when you solve quadratic, you always say plus or minus. But this time around, because I'm solving for the height, so this is going to be only the positive situation of that. That is 48. And you can really find out what is equivalent to in your calculator in decimal. So if you are to do that, let me check that. The square root of 48. Let me remove my calculator from statistics. This is square root of 48. I'm getting 6,93. I'm getting a 6,93. That is in centimeter. This is how you solve the value of h. If you have any question, like I always say, please comment to the section below. And thank you very much, guys, for watching. Today, I just thought, no, let me come and refresh with you with this topic of calculus in grade 12. Don't forget to subscribe to the channel. And thank you very much for watching.